This is problem 3-42E. It's on page 165. A measuring tape used by carpenters is 25 feet long and is made from flat strip steel with these dimensions. Width 3/4 of an inch, thickness 6/1000 of an inch. Compute the elongation of the tape and the stress in the steel if a tensile force of 25 pounds is applied. So the basic question is, let's say that you're trying to measure something and you've got your buddy at one end and you're at this end and you're pulling on the tape measure with 25 pounds of force, which is probably excessive, but could be done. And it's a 25-foot measuring length. How much are you stretching the tape? So how much are you overestimating the length? Let's find out. So we've got the various information. You can read the problem. Basically, our goal is to find these two things. How much is the tape stretching, and what is the stress in the tape? So let's start off by calculating the stress. That's the easiest one. It's just force over area because the, here let me sketch it. Basically this is like a rectangular thing. I can't draw it to scale, but you'll get the idea. Of course the long dimension is this one here. That's the 25-foot dimension. It's 3/4 of an inch wide and 6/1000 thick. So you can see the area I'm interested in is this area here. It's the basically the thickness times the width, and we know the force being applied is 25 pounds force. The thickness is 6/1000 of an inch, and the width is 3/4 of an inch. And so plug all that into your calculator. You'll find that the force being applied is about 5.56 KSI, or thousands of pounds. So this is it's over 5,000 pounds per square inch. The next thing, so that's one of our answers. The next thing to do is to calculate how much is the tape stretching. To me, this is the more interesting question because I want to know how far off is the measurement that I'm making here. So here's the equation for it, and you can find this equation. Let's see, it's in chapter 3. I'll find it for you quickly. It's one that you should become familiar with, and you'll get used to it and be able to just write it down by the time the course is over. But go to page 128. Equation 3.9 is essentially what I'm using here over and over again. So anyway, all we need is the stress, which we already have. We need the length, no problem. It's steel, so the elastic modulus is about the same for all steel alloys. Okay, so here we go. The tape, by the way, is 25 feet long. If you convert that to inches, just multiply by 12. You'll find it's 300 inches long. Elastic modulus, here's a number you need to commit to memory. Okay, 30E6 PSI. Since I have KSI up here, and that's the elastic modulus for steel, it'd be easier just to make that 10 to the third and make this KSI. That way the KSIs will cancel nicely. Plug all this in your calculator, you find that this tape will stretch by about 0.056 inches. So there's the answer, but in a practical sense, how far off are we? That doesn't look like very much because it's not even an inch. Well, it turns out a 1/16 of an inch, which tape measures usually, of course, have marked on them, is 0.0625 inches. And so you see that this is almost a 1/16 of an inch of error. And probably that's okay. Most construction projects, that really doesn't matter, especially around the home, of course. But it's something to be aware of. I wanted to add one thing to this video about the tape measure because you probably used one around your home. We talked about how much the tape would stretch given a 25-pound load. There's one more thing to consider here. If you ever notice at the end of tape measures, there's a little hook on the end. Basically, it allows you to hook onto things. You can butt it up to things to take your dimensions and have a reference point. You ever notice it's bradded on, or it's, rivets, brads, I don't know which it is. It doesn't matter, but it's made so that that hook, if the tape is here, the hook is made so it can slide a little bit at the end of the tape measure. You might wonder why that is. You might think, well, is this a bad tape measure? It wasn't made right? Well, the reason for that is so that the width of the hook is not important anymore. The thickness of the material at the end. Basically what will happen if your tape is here and your hook is here, if you hook the tape on something where your reference is against the face here, what will happen is the tape will slip enough to account for the thickness of the metal that the hook is made from. On the other hand, if you butt the hook up against something, then the tape can slide in, or the hook slides back relative to the tape, which again accounts for that thickness. So that's why there's some play with the hook at the end of a tape measure.